Hey guys, sorry I'm not there again today. Unfortunately, I got COVID, so I'm going to be out today and at least tomorrow. Hope to be back on Wednesday. So here I am making you this awesome video from my garage because that's the only quiet place at my house these days. And I just want to take a couple minutes to review what we have already learned about predicting weather so that you guys are ready to move on and we're all staying together as a class. All right, so last week we were working on Explore 1, which was the forecast for Omaha, Nebraska. And in this activity, we watched and plotted the movement of these warm and cold fronts as they moved across the country. Just as a reminder, weather typically moves from west to east, which on your iPad screen on this map is going to be from left to right. So as we made these fronts move across the country, we also were predicting the weather for Omaha. So the first front that got to Omaha was the cold front. The cold front is the blue one with the little spikes on it. And we noticed that it tells us right here that the weather that front brings is 50 degrees, which is colder, and thunderstorms. And the reason for this is that when a cold front moves in, it very quickly forces the warm air in that area to rise because we know that warm, less dense air is going to rise above cold, more dense air. So this warm air has a lot of water vapor in it. So when the cold front forces that warm air to rise quickly, well, we know from the water cycle that that's going to cause phase change. That warm air and that water vapor, as it rises, is going to cool off. It's going to lose energy, and it's going to phase change from water vapor into condensation or droplets of liquid water. And we know that causes clouds and precipitation. In this case, since it happens so quickly, it causes some pretty severe weather. Usually you're going to see a thunderstorm with a cold front. So then, after the cold front hit, we traced the movement of the warm front. And the warm front weather was 75 degrees and also rainy. So when that front got to Omaha, Omaha's temperature went up because the warm front is going to bring warmer air, and it's also going to bring precipitation. And this is because as that warm air moves in, it's encountering the colder air that's already there. And of course, we know the warm air is less dense, so it's going to rise. It happens more gradually than with a cold front, so you don't get the severe weather. As the warm front moves in, that warmer air that it's bringing just kind of gradually rises above the cold air that's already there. Condensation happens, you get clouds, and you get precipitation. But again, it's not that extreme weather that you get with a cold front. One of the things that this lab didn't really talk about was pressure systems. So let's say over here in, let's say us. So over here in Chicago, we have a low pressure system, and that's going to be a red L on our map. And so what happens here is basically we get warm, moist air rising. And so when that happens, that air goes up into the atmosphere, and it's cold up there. So again, we get phase change, we get lots of clouds, we get condensation of water vapor, and often precipitation. So a low pressure system is going to bring condensation, clouds, and rain. So again, that's going to be warm, rising air. If we say Wichita has a high pressure system, you're going to have the opposite. You're going to have cooler, denser air sinking. And so what that results down here for us is higher air pressure because that air is sinking down towards us, creating a high pressure condition for us, and that water vapor can't condense. So when you've got a high pressure system, you've got nice clear skies, usually not a cloud in the sky, and if there's no clouds, that means there's no condensation and there's no precipitation. So you're going to get a nice clear, no rain, no snow, no anything like that. Another thing that I wanted to talk about was a stationary front. So a stationary front, I'm just going to draw this in a color that's neither, well, We'll do red and blue. So a stationary front might have, oh, that's not right. I got a little spike, little spike, little spike, oops. And then it's also going to look like a warm front. So it looks like both combined, and it's because that's what it is. So when we get a stationary front, it's basically a warm front and a cold front push into each other, and neither is powerful enough to push the other one out of the area. So it just kind of stays there. And we know both of these fronts are going to bring rainfall. So if these fronts are just stuck here for days at a time, neither can push each other out of the way. If you live in Birmingham or Atlanta, you might get a couple days straight of rainfall because you are right at the end of two fronts and neither can push each other out of the way. And eventually it's going to clear up. Obviously, it can't rain forever. But if you are at a stationary front, it's a front that is not moving, and it is just bringing consistent rainfall for a couple days. Well, hopefully you found that review helpful, because guess what? Now you're going to go do the Explore 1 formative. So good luck with that. Please work on that individually. It's posted in Schoology. Once you finish that assignment, you're going to do the predicting weather, reading science. Guys, I always try to remind you of this because it's important. You have to actually read the article, okay? Please don't just wing it and skip to the questions and guess, all right? This is important. I need you to actually read the article. So read that, answer the questions. If you don't know the answers, go back, reread the article, find the answers. They are in there. After that, you've got a couple options. You can go into the review folder and play some of the review games that are posted in there, or you can do the coloring activity, which is you answering some questions that will tell you what color to color in certain parts of a picture. So I will post that in Schoology as well. Thanks for watching this, guys. I will see you hopefully back on Wednesday. See you soon.